Around 1.4 million people alive in the UK today have survived a heart attack, but survivors can suffer from debilitating heart failure because the heart is damaged during the attack. 10 years ago, the Naked Scientists spoke to Sian Harding from Imperial College London about some promising new heart patches that could be grown in the lab. 10 years on, production is now more reliable and plentiful, and it's hoped that safety trials on humans could begin within the next couple of years. I'm Heather Jameson, and I spoke to Sian to learn more.
The basic motivation is the replacement of muscle in heart attacks. We don't really have any treatment that will bring back the heart to its pre-heart attack condition. So you lose probably around about 1 billion cells in a given heart attack. And the heart regenerates very slowly, so only about 1% a year, and it really couldn't keep up with that kind of loss. And none of the drugs or therapies we have at the moment can do anything about that. So they can never really get people back to their pre-heart attack health.
And your solution is to put muscle back into the heart, muscle that is grown from stem cells.
That's right. So about a couple of years ago, about 2012, the Nobel Prize was won by a group from Japan who learnt how to reprogram normal cells from anybody into stem cells, pluripotent stem cells. So that's what we use. And we can turn them very efficiently into cardiac myocytes, so muscle cells, cardiac muscle cells. We can see them beating in the dish as they turn into these muscle cells. And so we now have a source of muscle that's matched to the person that you took the cells from, so potentially the patient.
And you can produce these into little patches.
That's right. So we make quite a lot of them, so about 20 million, and we suspend them in a gel, a hydrogel. And over about the course of about a week, they expand and they find each other and they start to connect. They go from individually beating to the whole sheet beating, and they grow around some kind of bendy support posts. And the gel solidifies around those support posts. And then when they start to contract, they bend the posts rhythmically. And in doing that, they exercise themselves, like you might exercise your muscle, picking up weights or something. And you can see it over the course of a few weeks. They get stronger and stronger. Then after about 6 weeks to 2 months, we then use them to implant them. So at the moment, we're making them about 2 by 3 centimetres and about 1.5 millimetres deep. But we could make them larger. We've been talking to our surgeons about whether we should make a much larger patch, but probably the ones we have are good because they can then use perhaps 10 or 15 and put them in different places to cover the damage that they can see.
So what stage are you at with this study at the moment?
Well, at the moment we're doing it on animal hearts. We're doing it on rabbit. We also can cut slices from human hearts. We get hearts that are taken out of the chest during transplants, and so we get pieces of those hearts. They're the discarded hearts. And we can cut very thin slices from those and keep them alive for quite some time. So we can look at how those cells, those pluripotent stem cells, interact with human tissue. And actually it's failing human tissue, so it's exactly the sort of tissue we would put those patches on.
So you can grow these patches from cells taken from the patient. Does that mean that we don't need to worry about the patient's immune system rejecting the patches?
So this is an interesting point, because if we take these cells from the patients and we make it from their own cells, they should be immune matched, and so they shouldn't reject them. Of course, it takes some time to do that, and it depends whether the patient is stable enough for it to allow us to do that and the timing of the operation is right. Also, it might mean that from a regulatory point of view, each one is a completely different product, which makes it a little more difficult and also not so attractive for an investor, just to be realistic. So we might want to make it something off the shelf. And so we could do that, and we could use immune suppression, which is just like the thing we do for heart transplants now. Not ideal, we'd prefer not to, but it's possible. Then the other thing we can do, and that we're trying to do now, is to genetically modify the stem cells so that they don't have some of the antigens that would cause that rejection, to make a kind of a universal donor like we'd have for an O blood group. And you could make large quantities in preparation for when somebody needed them.
It's exciting to think what the next 10 years has in store for this work. That was me, Heather Jameson, speaking to Sian Harding from Imperial College London, and that work was presented at the British Cardiovascular Society annual conference.